Hi, it's Joe Bell here, G4PMY. We've been working on this Marconi M3000 marine receiver. It's actually in strip down condition at the moment. Here you can see that the front panel is missing, and it's connected by this ribbon cable, and this is in fact the rear side of the front panel. We've already changed about 9 semiconductors in the power supply of this receiver. It was a silent key sale, and my guess is that the previous owner was technically capable, but had probably lost some manual dexterity. There was a large solder blob across one of the series voltage regulators, and that caused a major blow up. So we're just coming to the tail end of the repair. We've repaired the power supply, and the microprocessor board needed 2 RAM chips, 2 114s, and the fault we're working on now is that spinning the tuning knob either clockwise or anti-clockwise only increments the frequency, i.e. you can't tune in a downward direction at all, and the tuning knob itself is not acting correctly. It takes several turns to get one increment, and we're going to be investigating that. The tuning knob is an optical device. This is the rear side of it here, and basically on one side you've got 2 infrared emitting transistors, and on the other side you've got 2 infrared sensitive transistors as receivers, and there's a disc that spins in a gap between those that interrupts those light beams, and we'll be looking at that in a few moments. So we've opened up the PCB. PCB sits on these pillars, these standoffs, and this here is the disc that's mounted behind the tuning knob. You can see it's full of slots, and the semiconductor, which is down here, has a gap in it that the disc rotates in. The way it works is the semiconductors are arranged such that if you turn the knob clockwise, then channel A will be interrupted before channel B, i.e. channel A leads by 90 degrees channel B, and if you spin the disc anti-clockwise, then channel B would interrupt before channel A, so channel B would lead 90 degrees to channel A, and that's how the logic knows whether you're turning the knob clockwise or not. So the tuning disc, which you can see is full of slots, actually sits in the gap on the sensor, and as you turn it, then the light beam which travels across, there are 2 channels in there, channel A and channel B. If you turn it clockwise, then channel A is interrupted 90 degrees ahead of channel B, and if you turn it anti-clockwise, then channel B is interrupted 90 degrees before channel A, and that's how the system knows that you're turning it clockwise or anti-clockwise. The problem we found is that you can see the brass bush here that the tuning disc sits in, and that is now fixed. There's a circlip goes on the other side, and of course the PCB is fixed on these standoff pillars. What we found is that the disc is not sitting deep enough in the sensor, and so we've actually undone the Allen keys and moved the disc back and put a spacing washer in, because the distance between the circlip groove and the back of the disc itself has to be the length of the brass bush, otherwise the actual assembly would flop in and out. So by putting the spacing washer on, we've moved the slots deeper into the sensor, and that appears to be correcting the problem of non-tuning. So we're now in the process of actually putting the front panel back together, and we'll show you the radio set working in a moment. Okay, we've got the PCB back in and the screening can on, and we're just going to put on the knobs, and then we'll be mounting the front panel back into the case, and we'll show you the radio set working. So before we turn the receiver on, let's have a look at the case. It's a modular receiver. The board you saw on the other side was a motherboard, and the various modules plug into it. Here is the microprocessor board. As you can see, it runs in slots. This is the board we had to put the 2 RAM chips in. Power supply board, and of course the various RF boards interlinked with the jumper cables. There is a frame that goes on the back. These are the external voltage regulators. There are 3 Darlington transistors, and that plugs into the power supply board at this socket here, and that frame sits on the back of the receiver to act as a heatsink. So here's the receiver put back together. As you can see, we've got SSB, AM, RTTY, CW as working modes. We've got filter selections going from wide to narrow, and we've got AGC, off, slow, fast, and a 20 dB attenuator, RF gain, AF gain, a notch tune, a pre-selector, which is a variable capacitor to tune the front end, and then you've got scan, BFO, tune, which enables the tuning dial, an entry keypad, and because it's a marine receiver, we've got buttons to take us directly to the emergency channels, and a memory store. So let's turn him on. So we're straight into 2182. Let's see what's on 80. 3065, and peak the tuning, and we're in AM mode of course at the moment. Because this is a USB receiver, to get LSB we press the BFO, sideband, BFO, tune the BFO for -2 kHz, go back to tune, And there you see it working. Quite a nice receiver.